Hey everybody, it's Mr. N here. We are going to do the 5-7 lesson here. This is on congruent triangles. So basically it's just one main topic that we are going to cover today, and you already know this in the fact that we've already mentioned this and we've talked about this, but we are formally introducing it now. And it's this thing, CPCTC. All right, and some books will just say CP. Oops, let's use the correct pen here. Some books will just say CP. And I typically just say CPCTC. And what does it stand for? It means corresponding parts of congruent triangles are congruent. So in other words, if you've got two triangles here, and I prove to you that triangle ABC is congruent to triangle DEF, if I tell you that ABC is congruent to triangle ABC to triangle DEF, well, then you can tell me the parts are congruent. In other words, you can tell me that AB, right here, is congruent to DE. AC, right, would be congruent to DF, and you can look at it or do it by that. And I don't know why, I just noticed here, I don't know why I put a line above ABC, so let's see if I can erase that, if the software will let me. Sometimes it's finicky. Yep, it's finicky. It's not going to let me this time. Let's try it one more time. There it goes. Okay. So ABC and DEF, and then you can do the angles as well, like angle A would be congruent to angle D. It just means the corresponding parts will be congruent to each other. So we've pretty much done this. We've said if the triangles are congruent, then all parts of them are going to be congruent anyway. But this is it formally, CPCTC. That's how I'll write it. Again, you may see it as CP. All right, so let's do some examples over here, and we'll move on with this. We will do the student journal ones in class, but let's look here. It says fill in the blanks to complete each definition. Blank angles and blank sides are in the same position in polygons with equal number of sides. We'll say corresponding. Corresponding angles and corresponding. Two polygons are what if and only if they're corresponding? Congruent. Okay, next. Name the three pairs of corresponding sides. Okay, so we have to name the pairs of corresponding sides. So if I say GI, this would be congruent to JL. And if I say GH, this would be congruent to JK. Notice I have to name it JK because I went from 1 to 2 on the tick mark end. And then the next one over here, if I say I did okay, so IH is the one that's left. IH, that would be congruent to LK. Okay, name the three pairs of corresponding angles. So angle G would be congruent to angle J. Angle I would be congruent to angle L. And angle H would be congruent to angle K. All right, next, find the value of X over here. Okay, so we are, let me move this over a little bit so I can see what's going on. And we are given that triangle DEF is bigger than triangle LMN. So this triangle is greater. But I still need to find this X. Well, it doesn't matter if it's greater. The angles will still be the same, right? The sides will be different, but the angles will be the same. So D goes with L. So D right here goes with L. E goes with E goes with the M. So X is going to be 39. All right, given it's bigger, ABC is bigger than PQR. Okay, well over here I cannot solve for X straight out for a number. All I can say is that since this triangle ABC is larger, right here, let's highlight it, since this triangle is larger, all I can conclude is that this side right here, this 8.1, will be larger than the X. That's the only thing I can conclude there. Okay. And we're going to skip number 7 right here because there was supposed to be a graphic that went with it, but it got cut out. So let's move on to the next page where I do have a couple proofs that we want to do together. So in this proof, I do want to change something here. And this is what we're going to try to prove, is that AB is congruent to ED. And let's go ahead and put in our statements. And as I fix the spelling, statements, and then our reasons. Okay, step 1 will be our given that AB is congruent to DE and C is the midpoint of AE, and this is a given. And so we know this is a midpoint. And we are trying to prove over here, and I will highlight them in this color, that AB is congruent to ED. Okay, so let's see what we got. Over here, since I know that these two are parallel, and I know it's a midpoint, let's start with the midpoint part. Since it's the midpoint, I can say right away that those two are the same, right? Just like I can say these two are the same. Okay, so I can go ahead and state that AC is congruent to EC, and I can say BC is congruent to DC, and this is all by definition of midpoint. So now I'm going to say that angle ACB is congruent to angle ECD, and these are vertical angles. There are a couple different routes you could take for this proof, and I will show you another one in a second. But I think this one right here is the quickest, or at least maybe the easiest. So I said those are congruent. So now I can say that triangle ACB is congruent to triangle ECD, and this is by side angle side. Well, since these two triangles I've just proven to be congruent, right here and right here, it'll fall that all their corresponding parts are congruent, so that means AB will be congruent to ED, and that's by CPCTC. Okay? Now, another route you could have taken is, since they said these are parallel, I could have said that angle A is congruent to angle E, and then I could have done the vertical. Then you could have said angle side angle. You could have said angle A congruent to angle E, then angle B to D, and you could have done angle side either way, right? So there are a couple different options and a couple different routes to take to prove that one. Let's look at the second one. Okay, let's make our T-chart. Here's our statements. Here's our reasons. Let's look at what we got. We are given that VB bisects, that's an E, VB bisects angle EVO and EBO, so it's an angle bisector, and I need to prove that angle E, this one right here, and let's highlight it, is congruent to angle O right there. So those are the two angles that I am trying to prove congruent. Okay, so we're going to take the same route. Let's go ahead and first state the given. VB bisects angle EVO and angle EBO. This is our given. All right, let's always start with the one that's obvious right here. That's reflexive. So BV will be congruent to BV, and that's by reflexive. What I'm trying to do is I'm trying to prove that this top triangle is congruent to that bottom triangle. Well, I already know the reflexive part, and since that is easy to do, let's see what we could do with the angles, because I'm given a bisector of an angle. So that's my next step is, okay, I'm given something that bisects angles. Well, that means I know that angle 1 will be congruent to angle 2. Angle 3 will be congruent to angle 4. And now I can say that these two triangles will be congruent, again, by angle side angle. So let's write that up. So angle 1 is congruent to angle 2, and angle 3 congruent to angle 4. This is by definition of angle bisector because this cut those angles in half. That's what we were told. So that means that triangle BEV is congruent to triangle BOV, and this would be by angle, side, angle. Well, if the triangles are congruent, then we know the parts will be congruent. So that means angle E will be congruent to angle O, and that's by CPCTC. All right, and that's it for this lesson. Hopefully this made some sense. I know some of these proofs take a little bit of practice, but keep going at it. So hit that like and subscribe button, and I'll see you guys in the next video.